Hi, in this video we'll look at transport layer of OSI model. So in the previous video we looked at network layer, and now it's time to gear up and look at the transport layer and understand what it does, how it works, and what it would give us in terms of ethical hacking. So the transport layer is the layer that NMAP utilizes the most. So in terms of hacking or network scanning, this layer is really important to understand. If you don't understand this, there would be problems understanding the results of a network scan or when we are collecting information on a target. Now that we know that the transport layer is really important, now let's understand what it is and what it does. Okay, so the transport layer is used for the transfer of packets between two hosts for the application layer. Don't get scared, it's pretty easy. We'll look at it as we go along, but first let's understand what kind of protocols it uses for its operations and what are their jobs. So the first protocol that it uses is ICMP, which is Internet Control Message Protocol. We'll look at it in a minute and understand what it does, but right now let's just go through the names of all protocols real quick, and then we'll understand everything in details one by one. The second protocol that it uses is the UDP, or User Datagram Protocol. The third one is TCP, which is Transmission Control Protocol. Now let's understand all of the protocols one by one in great details. So ICMP, which is Internet Control Message Protocol, you can see that it's an error reporting protocol that is used by the routers, host, network devices to generate error messages when there is a problem delivering a packet. So the primary function of ICMP protocol is that it sends messages in times of errors and also sends other things in times of problem delivering packages. In other words, it's used to perform network diagnostics. We will look at this when we are performing a network scan, and I'm sure you will be really excited on knowing how it works practically. But the important thing to note right over here is that ICMP is just used to send error messages and probes and not the actual data. By that I mean that ICMP is not transport protocol that is used to send data between systems. It just sends error messages and that's it. The real data is sent by something else. Now coming towards its header. ICMP messages or flags are of two types: the request and response pair, which revolves around echo request and timestamp request. Now you cannot understand these without a practical example, so for that you have to wait till next few videos. But just to give you an overview, if you are doing a network scan with Wireshark, you can try to understand ICMP messages, because ICMP messages contain two types of code, which is queries and errors. So the query messages are the information we get from a router or another destination. For example, you can see the type of messages on your screen. Anyway, we will look at it when we are performing a network scan. Right now, just understand that the ICMP messages or flags are of two types: the request and response pairs. Now coming towards UDP, User Datagram Protocol. The UDP is used for establishing low latency connection between applications on the internet. The two common features of UDP is that it is unreliable, in a sense that it has no guarantee of delivery to the destination. And the great thing about it is that it is connectionless, in a sense that it doesn't require a handshake process. We'll discuss this handshake in a separate video to explain all how it works and how the stuff is. But for now, just do know that UDP is used for low latency connection between applications on the internet, and it's unreliable and it doesn't require any handshake process. So that makes it extremely fast. Anyway, let's look at its header. So the UDP header contains source port, and it would be a port selected from all the unused list of ports, like one random port from your system, which is free. And it also contains a destination port, which is also port selected from the static and well-known ports. Like its example could be a web server running on your local machine uses port 8080 by default. So is Skype running on your machine that takes up the port 8080. I think the Microsoft has changed that by now or not, I'm not sure, but I think you got the point. Now let's come over to TCP, which is the last transmission control protocol. TCP is a standard that defines how to establish and maintain a network conversation via which application program can exchange data. So that means that it's a protocol that governs how the devices can make connection between them and then obviously exchange data. Now the good thing about TCP is that it is very reliable and ordered. Now let's look at its header real quick and then we'll end the video there because I think it's getting a bit longer than expected. The TCP header contains source port and destination port as of UDP, but it also contains flags. For now, let's leave the flags because we'll discuss this in our next video where we will take complete overview of handshake and how the three-way handshake works. So this is pretty much it for this video. I hope you did learn something. If not, the next video is coming real soon, which is on TCP three-way handshake, and in which I will explain all of the points which I left in this video. So till next time, I'm out. Stay cheeky breaky and peace out.